Welcome to the deep dive. Today we're going inside the body, metaphorically speaking anyway. We're going to dissect a really vital tool in interventional medicine. It's the endoscopic loop ligator. You might just know it as the ender loop.
hmm
And for this deep dive, our whole foundation, it comes from a fantastic source. It's Dr. G.S. Raju's YouTube video, specifically the one titled HCC 1472 Lesson 11A4 Hemostatic Devices Loop Ligator.
Great visual guide really lays it out.
Absolutely. And our mission really, it's straight from that video. We want to properly understand how this device is used, in general endoscopy. And maybe most importantly, get a grip on the high stakes choreography of actually handling it.
Right, because this isn't just theory.
No, exactly. This is really a deep dive into managing risk. If you understand this device, you understand how to handle a situation where, well, getting it wrong means potentially severe bleeding, high risk bleeding. So let's unpack the main problem this thing solves.
Well, it's interesting because the device, it's specifically designed for sort of an anatomical challenge. We're talking about dealing with those large polyps, the ones endoscopists call pedunculated polyps, the ones with a really thick stalk.
Okay, so that thick stalk, that's the red flag right away. For listeners, maybe, who know basic endoscopy, why is cutting that kind of stalk so much riskier than, say, a smaller lesion?
It really comes down to the plumbing inside, you could say, volume and density. A thick stalk often means there are multiple large feeding vessels packed in there, big arteries.
Hmm.
So if you just go in and cut it like any other polyp with a standard snare, you're essentially opening up those major vessels. The loop ligator exists purely because of that high risk of hemorrhage. It's significant.
Yeah, and the source video really points out this risk isn't just, right there on the table. It mentions two distinct times bleeding can happen.
That's correct. Yeah. First, you've got the immediate bleeding
Mm.
right there during the procedure,
Mm.
which is obviously bad enough. But the second risk, and you could argue it's actually more dangerous, is delayed bleeding. That might happen hours or sometimes even days later after the patient's already left the hospital.
Okay, why is that delayed bleeding more insidious or harder to manage?
Well, sometimes the initial cut, maybe with cautery, it creates a sort of temporary seal,
Right,
a scab or a clot. But then, the patient starts moving around, maybe their blood pressure changes,
right,
and that temporary fix can just fail
yeah,
catastrophically.
right.
And the patient isn't under observation anymore, so it often means an emergency trip back to the hospital.
Huh.
The loop ligator, the whole point is to prevent that entire scenario. It does it through ligation.
Ligation. So for listeners, that basically means tying it off, right? Choking off the blood supply before you cut.
Exactly.
It's like the ultimate measure twice, cut once for endoscopy.
Precisely, yeah. The whole logic is
Yeah.
deal with the blood vessels first. You bring the ender loop down, you position it really tightly around that thick stalk below the head of the polyp, get it tight, deploy it, and now you've essentially put a permanent tourniquet on those vessels inside. Only then, once that ligation is totally secure, is it actually safe to go ahead and cut the polyp off. That's the core strategy, minimizing that risk.
Okay, that makes sense. So that brings us to the device itself, the mechanics. You have to understand how it works to understand the safety. Like you said, it's a long catheter, like most scope tools. But the handle, the controls, that's where the clever engineering seems to be.
Yeah, and what's really interesting is how it splits the job, between reversible steps for safety and then the irreversible commitment. The basic setup is simple enough. You've got the catheter tube itself running through the scope, and then the handle at the other end. And on that handle, there are two main things your hand interacts with, a thumb ring and a slider.
And then there's that plastic sheath you mentioned. That seems to be the key for the reversible part.
That's your main control for positioning.
Yeah.
That plastic sheath, it covers the wire loop inside. If you push that sheath forward, it actually pulls the loop back into the catheter tip, so the loop closes.
Right.
Then, if you pull the sheath back towards you, the loop comes out. It opens up.
So moving that sheath back and forth, that's how the operator can, like the source says, play with the loop, adjusting the size, getting it perfectly placed.
Exactly. That's the crucial thing for anyone learning this. That sheath control part is totally reversible. You can open it, close it, adjust it, wiggle it, push, pull. You can do that again and again, multiple times until the endoscopist looking at the screen says, yep, that's perfect, right on the stalk.
Yeah.
It's the low stakes part, the adjustment phase, your safety net, really.
That's a really important distinction. So you can basically rehearse the closure. You can get the position just right without actually committing to the ligation yet.
Precisely.
Okay, so it's that jump from the adjustable phase to the final commitment that's the really critical moment.
Absolutely critical.
Right. Let's shift to that moment then, the deployment. This sounds like it needs perfect communication between the endoscopist and the assistant who might be holding the handle.
Oh, absolutely. Total coordination is key. So the procedure starts, you introduce the device through the scope's channel, but it's in the closed position. Sheath forward.
Keeps the loop protected.
Right. Safe insertion. Then you get to that reversible phase we talked about. The endoscopist is steering the tip, getting the loop over the polyp's head, guiding it down onto the stalk, and the assistant holding the handle is using that sheath, making tiny adjustments, open a bit, close a bit, until the endoscopist confirms, okay, stop. That's perfect. It's tight on the stalk.
Okay, so position achieved, now the control shifts away from that reversible sheath onto the irreversible slider. Tell us about the hand position and the two really crucial actions that follow.
Yeah, this is where the handle design really matters. That thumb ring and slider, you can think of them almost like a two-stage safety lock, prevents accidental firing. The operator, they put their thumb into the thumb ring, then their index and middle finger go onto the slider. That specific grip gives you stability and control. It's pretty much mandatory.
Okay. What's the first commitment? Action one.
Action one is tightening. This happens when the operator closes their hand, like making a fist, pulling that slider towards the thumb ring, that engages the mechanism, and it starts actually tightening the wire loop around the stalk. And this is the point of no return. The source video really stresses this. Once you engage that slider, once you start tightening, there's absolutely no going back.
Wow. Okay. That moment must need, like, total focus and clear confirmation from the endoscopist, right? Knowing ligation is happening now.
It really does. They tighten it until they feel, adequate compression on the stalk tissue. Once that tightening is done, and crucially, the endoscopist says the word deploy, then comes the final step, action 2, deployment. The operator simply opens their hand back up. That action releases an internal lock, it unhooks the loop, and the loop just detaches from the device entirely. So it leaves that tightened loop permanently clamped around the polyp stalk, and the device itself can then be pulled out.
That distinction is just so critical, isn't it? The sheath is for reversible positioning. The slider is for irreversible commitment and deployment.
Absolutely.
Understanding that sequence, it seems, is key to avoiding mistakes, like deploying too early or not tightening enough.
That's exactly right. It minimizes those risks.
So, okay, the loop is deployed, it's tight, it's irreversible. What's the immediate effect on the polyp physiologically? We know it's squeezed, but what's happening inside?
Well, the body reacts pretty dramatically to that kind of intense focused pressure. When that loop cinches down hard around the blood vessels in the stalk, the pressure itself causes the vessel walls to just go into spasm.
Ah, okay, like they clamp down themselves.
Exactly.
Yeah.
So you get that vascular spasm plus the mechanical crushing from the loop, and it just immediately shuts down the blood flow, stops it cold. And what you often see then, which is a great sign it worked, is the polyp itself tends to sort of visibly shrink a little.
Because the blood supply is cut off?
Precisely. It's deflating, essentially.
That's the visual cue that, okay, this area is now safe to cut.
That's it. Once you see that, or you're confident the flow is stopped, then you can proceed without worry. Bring in the cutting snare, remove the polyp nice and clean, and the result should be no bleeding. You've managed both the immediate and the delayed risks.
It's pretty amazing how just a simple mechanical tie can trigger such a strong biological reaction. But the source material also mentioned the loop isn't just for polyps, right? That closing power has other uses.
That's right, yeah. While dealing with those thick-stalked polyps is definitely its main job, its star application, the Enderloop has been adapted because fundamentally, it's really good at bringing tissue edges together tightly, firmly. So that ability makes it useful for other problems in the GI tract too, specifically closing perforations holes or maybe repairing large defects left behind after you remove a really big lesion.
So it acts like a stitch, but without needing a needle and thread, a mechanical closer.
Exactly. A non-suture suture, you could call it. Very powerful mechanical closure.
Okay, so this has really been a deep dive into precision, hasn't it? Where every little part of the device, every movement has a critical, potentially life-saving job. I think the core takeaway for me is that split function. You've got the reversible, super adjustable plastic sheath for positioning safely, and then you've got the irreversible slider mechanism that commits you to the final hemostatic action.
Yeah, and if you think about that, the whole technique, the way you handle it, it's completely designed and optimized for achieving that extreme vascular occlusion, right?
Yeah.
Getting it tight enough to make those vessels spasm and completely cut off the flow. That's the goal for polyps.
Which leads us perfectly into our final thought for you, the listener. Given that the whole mechanism, the handling, it's all geared towards inducing spasm and crushing vessels when you're dealing with polyps, how might the goal, and therefore the technique, maybe even the amount of tension you apply, how might that change when you use the endoloop for its other job, for closing those large defects or perforations?
That's a really interesting point. Because there, your main goal isn't necessarily to crush a vessel until it spasms, right? It's more about just bringing the tissue edges together neatly. Apposition, they call it.
Right.
So does that mean you still crank down on that slider with maximum force? Or would you maybe use a gentler touch? Just enough to close the gap. It definitely raises a fascinating question about adapting the tool to the specific task at hand. Something to think about.
Indeed. A great point to ponder. Go forth and deploy this knowledge responsibly. Thanks for joining us on the Deep Dive.
Catch you next time.